OK, so with those little implementation footnotes out of the way, now we can start thinking about how to take those English sentences that we saw that made sense to us as humans and encode them in actual records. Once again, for backwards compatibility, we're sticking with records. We're not switching to some other type of data storage. DNSSEC uses records because DNS uses records. So here are some extra types of records that are useful. We'll look at 3. One is called RRSIG. That's where you put signatures. So if you ever have a digital signature, use that data type. Anytime someone wants to send their public key, use the DNSKEY type. And anytime you want to send a certificate, or you're passing trust to someone else, use the DS record. So those are the 3 data types, one for signatures, one for public keys, and one for delegating trust to other people. So that's the high-level stuff you have to know. If you want to know exactly what's in the records, you can read this, but I won't read them. But you'll see that there's some metadata that we normally don't talk about, but someone implementing this in real life would have to know. So when we're talking about how this works and how you think about it, you probably don't care about exactly when the signature was generated and when it expires. But if you were actually writing code to support this, you would probably have to know how all of this stuff works. But we don't have to, so I'll speed through this. But you're seeing there's some fields that we don't talk about. OK, so real-life implementation requires more metadata. You have to be a little bit more precise, but it's not the most interesting thing. So we won't talk about it further. But it's there if you want to read about it. OK, back to the land of in-scope slides. There are 3 types of records that we talked about. So let's go through each one. One that is a little bit unintuitive is how you delegate trust. So it turns out that delegating trust, where you say, you trust me.edu, I'm signing berkeley.edu's public key, so now you trust them. This kind of sentence has to be encoded using a combination of 2 records. The first record is a DS type record, and this is where you put things like, the next name server is berkeley.edu, here is their public key. And then the second record is a signature type record that signs the DS record that you just provided. So the way that you delegate trust to someone else is you say, here's a DS record that tells you who they are and what their public key is. And then the RRSIG record signs the DS record. Those 2 things together form a certificate. So that's how certificates are encoded. It's a combination of 2 records. That's the one that's a little bit weird. The other ones, like signing A-type records for answers, you would just use RRSIG. And encoding your own public key, you would just use DNSKEY. So the other ones are pretty intuitive. The one that's a little bit weird is forming a certificate, which requires 2 records instead of 1. And one little footnote, at the risk of getting too in the weeds, is that this DS record does hash the signer's name and the child's public key. So it doesn't give you exactly what their public key is. It gives you a hash of their public key. I actually don't know why they do this. My guess is that it takes longer data and makes it shorter, but not an important detail that you have to know. Just know that these 2 records together form a certificate.